A company has an investment opportunity costing 40,000 with the following expected net cash flow after tax and before depreciation. We've been given years net cash flow and we've been asked these different methods in capital budgeting. It's a fairly easy sum. We have a single project that we need to look at. So let's go ahead and make the basic table first. We have year. We have to calculate discount factor. Okay, and discount factor, we've been given two of them at the rate 10%. And again, we need to calculate it at the rate 15%. So maybe we can do them together. I think that will be better. Discount factor at the rate 15%. Next, we have cash flow. We also have to calculate cumulative cash flow. So cumulative cash flow. Similarly, discounted cash flow at 10% and discounted cash flow at 15%. This should more or less look after the methods asked. Right, so we have years 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we need to calculate discount factor. Remember, the formula for discount factor is always 1 upon 1 plus r raised to the power of n. So for example, 10%, we'll do 1 upon 1.1 raised to the power of n. And similarly for 15%. Okay, so this is for 10%. For 15%, we'll do 1 upon 1.15 raised to the power of n. If you're using a normal calculator, then it is 1 divided by 1.1. You press equal to, you'll get 0.9090, and that's non-terminating. You need to round it up. 4 decimal places should be good, so 0.9091. Now, if you press the equal to sign, you should get raised to the power of 2. So we end up with 0.8264. Again, you press the equal to sign, you end up with 0.7513, 0.6830, 0.6209, 0.5645, 0.5132, 0.4665, 0.4241, and finally 0.3855. Now, we repeat the same thing for 15%, so 1 divided by 1.15, which gives us 0.8695, which we can actually round up to 6. So take this as 6. Next, we get 0.756 1, 0.6575, 0.5717, and again we can round this up to 8, 0.4972. Similarly, 0.4323, 0.3759, 0.3269, 0.2843, and finally 0.2472. Now we have discount factors, and just in case you haven't got it till here, I'm showing it to you all on screen. Use your normal calculators which are allowed in university. Okay, on a simple calculator, if you simply take 1 divided by 1.1, press equal to, you'll get the first one, and then just keep pressing equal to and go down the line and get all the numbers you need. Okay, similarly we take 1 divided by 1.15 and the same logic all the way down, round it up to 4 decimal places, and you have your numbers. Now, as far as the cash flow is concerned, we've been given numbers. We have 7,000 all the way up till year 5. It's exactly the same, 7,000. Thereafter, it becomes 8,000, 10,000, 15,000, 10,000, and 4,000. Now, as far as cumulative cash flow is concerned, the need to do that comes from the payback period question. We are investing altogether 40,000. We want to find out in which year are we crossing that number. If it was 7,000 all the way, we could have simply divided, but because it isn't, we need to make use of the formula payback period. Payback period is equal to y1 plus investment minus cumulative cash flow at y1 divided by cash flow at y2. So we have 7,000 plus 7,000 gives us 14,000. Repeat all the way. Not that it helps if you know the 7 times table, but you are allowed a calculator. Now, I am crossing 40,000 being the investment in year 6, but now that we've reached here anyway, let's just go all the way. I am crossing 40,000, which is my investment, between years 5 and 6. So I can say that payback period is equal to 5 plus 40,000 minus 35,000 upon 8,000. Which gives me, alright, and on the calculator you can finish off 5,000 upon 8,000, which gives you flat 0.625, which itself, if you multiply into 12, you'll get 7.5. Okay, why 12? Because we're talking about 12 months. So let's see. if you were to take this forward, our payback period would end up being 5.625 years or 5 years and 7.5 months. Now, we are done with the payback period. We are done with this. Next, they want payback profitability. Payback profitability is a very simple formula. Payback profitability is equal to total cash inflow minus total cash outflow, and you can also think of this as investment. Okay, so our total cash inflow, we can think of it as the final number in the cumulative, which is nothing but the addition of all the cash flows. So if you were to add all of these numbers also, you'd end up with 82,000. Okay, so my total cash inflow is 82,000. My investment is 40,000. So we take 82,000 minus 40,000 and we get payback profitability is equal to rupees 42,000. Alright. Now we are done entirely with A. Next, we need to find NPV. Next, we need to find NPV at 10% and 15%. Right, we have got our discount factor at 10%, which we need to multiply into our cash flow. So, for example, we take 7,000 and multiply it by 0.9091 and we get 6363.7, which we will write as it is, 6363.7. Alright, and we're going to do that for all of them and get the numbers. So after having done the multiplication for every year's corresponding discount factor 10% in cash flow, we end up with all of these numbers. Alright, now we need to take a total. And that total is 48,953.4. Now you need to keep in mind net present value, or NPV, is equal to total discounted cash inflow minus total discounted cash outflow. And in most of the cases, the discounted cash outflow ends up simply being the investment. Alright, there's hardly a sum where we come across outflows in subsequent years. The only outflow that has taken place for us was when the investment of 40,000 was made. So this is our total discounted cash inflow. From this, we subtract investment, which is 40,000, and we get ourselves NPV. Okay, so 8,953.4. Okay, and yeah, make sure there's enough space for the next one. We repeat the same process by multiplying discount factor at 15% into the cash flow in order to get this. So for example, the first one is going to be 0.8696 into 7,000, which gives us 6087.2. And now we do it for all of them and take a total. Same thing will be subtracted from 40,000 to get ourselves the NEV. So we end up with a total of 39,417.9, and if we subtract 40,000 from that, we end up with a negative number. Keep in mind the criteria for deciding the acceptance or rejection of a project is whether or not NPV is positive. Since it's negative, I'm writing it in brackets, and we have to reject if we take it at 15%. Obviously, if our cost of capital is 10%, we are in a positive NPV. In this case, we can accept. Now, we are done with NPV, and being able to calculate profitability index at this point becomes easy because most of the heavy lifting is done. If NPV involves subtraction, profitability index or PI involves division. So profitability index is equal to discounted cash inflow upon discounted cash outflow. Okay, so if I really wanted the PI over here, I'm simply going to divide. So it's going to be 48953.4 divided by 40,000. So I end up with 1.2238, which I think should do. And similarly, I'm going to end up with 39,417.9 divided by 40,000. So 0.9854. Since this is more than 1, we accept. But if we stick to this, it is less than 1, and therefore we reject. Now, we've been asked to do one more calculation in capital budgeting, which is called the IRR. Now, IRR means that rate of return or that cost of capital, which when multiplied by cash flows gives us 0. So IRR is that rate where NPV equals 0. The formula for IRR is R1 plus NPV at R1 divided by NPV at R1 minus NPV at R2 into R2 minus R1. Now, for our sum, R1, if you notice, is 10%. Okay, and R2 is 15%. Our NPV at R1, we ended up with 8953.4 divided by 8953.4 minus, and keep in mind that number is also minus. So minus 582.1. This whole thing into R2 minus R1. Alright, so taking this further, we end up with 10% plus 8953.4 divided by, keep in mind minus minus gives you plus, so you end up with 9535.5, and then we divide, so 8953.4 divided by 9535.5, okay, and of course into 5%. So now we end up with 10% plus 8953.4 divided by 9535.5, which gives us 0.93895. Okay, so no problem, let's take it up to 5 decimal places into 5%. And remember, everything is in percent, so let's not upset the apple cart by doing away with the percent signs. Okay, let's take 0.93895 into 5, and we end up with 10% plus 4.6947 69475%. Now I think we are safe to round up. Maybe we can say this is 14.70%. Okay, therefore IRR is equal to 14.70%. If we were to use 14.70 back in this entire calculation from the beginning, instead of taking it at 15% or 10%, if we took it at 14.7%, we would have ended up with an NPV not of this or this, but of something very close to 0, if not exactly 0. Right, with that we are done with the sum, 15 marks.